Hi guys, my name is Jürgen.
And my name is Mait.
Uh, we are two ordinary Drupal developers from a company called Phenomen, who has never given a speech before. So I'll start by saying that our English is not that fluent as you would expect from an ordinary guy that gives presentations at conferences, because we have quite a large amount of topics to cover, and the amount of time that have been given to us to perform this presentation is finite. We have left no room for any improvisation, and will gladly use this little assistant called Kindle as our guide today. So we hope that you don't mind, because the topic, in our opinion, is quite interesting. Now that we have your attention, and you know what to expect from this presentation, let's talk about Drupal and Docker. How can these two technologies work together, and why you should care? Like most of the presentations out there, we have given a title to this one as well, which is Using Docker to Boost Your Development Experience with Docker. We have divided this talk into two major parts. The first part introduces Docker, what exactly is it and how it works. On second part, we will be discussing how we at Phenomen ended up using Docker and what problems it helped us to solve when developing Drupal-based projects. This presentation is primarily meant for beginners in general, but we are hoping that some of you who think that they already know Docker still might learn something new from this talk. Docker is a piece of technology that allows you, the developer, to wrap your application and all of its dependencies that it needs in order to run into a standardized package, which you can run virtually in any host. The only requirement to get your application running in 98% of the time is that you also need to have Docker installed on that host. Because Docker relies heavily on Linux kernel-specific features, you can currently run Docker natively only on Linux. But there are official and unofficial ways how you can run it also reasonably well on non-Linux hosts. Let me take a drink. I'm thirsty. Docker also gives you tools so you can share your application with others with ease. That is, I think, the most simplified high-level explanation I could think of how I will describe Docker to a Drupal developer that has never used Docker before. There is obviously much more to Docker than I have managed to describe in that short description, but we will focus mostly on these aspects of Docker in this presentation, since these are the most important features that you should be familiar with if you want to boost your development experience with Drupal using Docker. Okay, Docker only runs natively on Linux. However, not everyone is using Linux today as their primary development environment. Fortunately, there are multiple options for running Docker on a non-Linux host. The most portable and flexible way to use Docker on non-Linux hosts is to use whole system virtualization technology. Our personal favorite is VirtualBox, that allows you to create and manage virtual machines, in my opinion, very beginner-friendly way. It can run on many different operating systems and supports a large number of guest operating systems, including Linux. The primary downside using plain VirtualBox or any other hypervisor is that you have to do most of the initial configuration yourself manually. Normally, developers are not interested in wasting their time configuring their environment, but instead they just want to get their development environment up and running as fast as possible, so they could start working on their project. So just using VirtualBox to run Docker may not work for everybody. The other option is to use VirtualBox with combination with Vagrant. Vagrant has a good support on many mainstream operating systems like Windows, Mac, and Linux. I'm sure some of you here already are using Vagrant today, but probably provisioning the guest operating system with the more widely used provisioners like Classical Shell or more advanced configuration management tools like Ansible, Puppet, etc. This is a widely used and working setup to get your development environment up and running. But since this presentation is mostly about Docker, we can take a step further and provision the guest operating system and manage Docker on it with Vagrant as well. Since it has an official provisional created to support Docker. If you're already using Vagrant, then this option is probably best for you. The official and recommended way to get started with Docker is to use very recently announced tool called Docker Toolbox. If any of you are familiar with boot Docker, then you should know that Docker Toolbox is here to replace it, and it is suggested that you migrate as soon as possible. Docker Toolbox is basically a collection of tools to help you get started with Docker quickly on non-Linux hosts. The end goal of these tools is to provide you a similar experience and the same functionality as you would expect when using Docker directly on Linux. Unfortunately, an essential tool for having a great development experience with Docker, called Docker Compose, doesn't work on Windows. So I don't recommend using Docker Toolbox on Windows just yet. But I'm absolutely sure that it will be supported on Windows in the future. Until then, I will use Vagrant in combination with VirtualBox on Windows. But if you're a Mac user, then Docker Toolbox should definitely be your first choice working with Docker, because the support for Docker and other tools in Docker ecosystem on that platform is superb. The architecture of Docker in a nutshell, in context of this presentation, consists of two primary parts, Docker Engine and Docker Client. Docker Engine is basically a daemon that runs continuously on your machine as a service. Docker Client is a command line tool that the developer can use to interact with Docker Engine. Because Docker Engine and Docker Client can speak TCP to communicate with each other, these two programs don't have to be running on the same machine, which gives you a flexibility to run and manage your Dockerized applications very conveniently on remote machines over the network. The same flexibility allows you to use Docker very seamlessly, for example, on Mac or Windows. Despite that, the Docker engine can run only on Linux, you can still run it in Linux-based virtual machines. And since Docker Client doesn't depend on Linux kernel-specific features like Docker Engine does, there are binaries for Docker Client that you can run directly on Mac or Windows. So when the developer interacts with Docker Engine on Mac or Windows, he still has a sense of feel that the host he is using can run Dockerized applications natively. So what makes Linux so special that Docker Engine can run natively only on that operating system at this time? Some of you may know that Docker is a containerization technology. In other words, it means that your Dockerized applications, also known as containers, are running in isolation from other processes on the same machine. The isolation is done by the host's operating system kernel itself, and not by some other piece of the software, like in case for virtual machines, where the hypervisor is in the role that isolates your guest operating system from the rest of the system. However, not all mainstream operating systems today are supporting container-based virtualization. By that we mean Mac and Windows. So our theory is that since Linux is considered a mainstream operating system in the technology world, and the Linux kernel does support container-based virtualization, then the only logical conclusion is that there were no other feasible options available to choose from. Then you might ask, what about operating systems like FreeBSD and Solaris that are also supporting this container-based virtualization concept? I'm pretty sure that in the future, these operating systems will be supported by Docker natively, because Docker has been built in a way that it supports switching between different execution environments. Basically, you can write an execution driver for Docker Engine for your operating system if it has some kind of containerization primitives in place that will allow a process to run in a sandboxed environment. As far as I know, there already is an execution driver available for FreeBSD that utilizes the jails mechanism on that platform to isolate processes, although it's still considered as an experimental project. And also Microsoft has started to understand the importance of containerization technology by adding containerization primitives to the Windows kernel, which currently are only available in the just released Windows Server 2016 Tech Preview 3. So expect to be able to use Docker on Windows in the future as well. From a developer point of view, the two primary advantages of container-based virtualization over whole system virtualization is the efficiency. How many applications you can run in parallel on a single machine, and the speed. How quickly you can start and rebuild your application. A typical virtual machine is usually a couple of gigabytes in size. It takes minutes to start and many more minutes to rebuild it from scratch. The overhead you have when running your application in a virtual machine is much larger than running it on your host natively. The amount of virtual machines you can run on an average laptop is relatively low. I would say if you try to run more than 10 virtual machines on your laptop, then you may already start experiencing performance degradation. For a developer, these numbers are not that appealing, and because of that, they usually run their development tools directly on their host because it's faster. However, by doing so, they lose some of the flexibility over the development environment. The whole point of isolation that virtual machines or containers can provide you is that you can have the same set of tools with different configurations and versions seamlessly on the same machine without ever conflicting with each other. And this is why some people are still willing to use virtual machines to develop their projects, because the benefit they can get from isolation outweighs the performance impact that using virtual machines have on their system. These are the exact issues that you can solve by using containers instead of virtual machines for development. The primary disadvantage of container-based virtualization in practice is that you cannot run applications in containers that are compiled for a different operating system as your host. For example, you can't run Windows-based executables directly in a container if your host operating system is Linux. There is no such limitations for virtual machines. Using containers mostly wouldn't be a problem for a Drupal developer, because most of the third-party services that are usually used in alongside with Drupal are able to run on Linux anyways. Now that you have a better understanding of some fundamentals that enables Docker to do its work, we are going to explain you next some of the internals about Docker in more detail. One of the building blocks of Docker is the concept of image. A Docker image is a read-only template, which in simply put is a collection of files that your application needs in order to run. For example, an image will contain a Linux distribution like Debian with Apache and your Drupal project files. It is very similar conceptually to a tarball, which is a collection of files and directories which you can move around as a single unit. Depending on your application and its dependencies, the Docker image can be either very small, something around few megabytes, or very large, from a couple of gigabytes to infinity in theory. Docker images can be pushed into centralized registry, where other parties can easily pull it to their machine. There are several companies that are providing public and private registries on the internet today. Docker, a company behind the Docker project, also provides a public registry to everyone to use for free, and a private registry for a fee. The name they have given to that service is called Docker Hub. I definitely recommend you to use Docker Hub if you need to make your images easily accessible to others. Docker registry is also available as an open source software, so you can set up a private registry relatively easily on your own server. Using a registry requires usually access to a network, so in case where your machine is not virtually able to communicate with the registry, there is always an option to export an image to a file, which you can move around through other mediums. There are a couple of ways how you can build a Docker image. You can build an image either by hand or in an automated way. The problem building an image by hand is that, for example, if you have already built an image by executing a series of commands on top of each other, and you're required to make a change to that image in the future, for example, you may need to update the library that your application is using or patch a vulnerability for a third-party service. And let's say several months goes by and the change will not be done by you, but by another developer that didn't build this image himself. He probably don't have any clue how the image was made and what exactly is packed into that image, because there is no history nowhere to be found that will tell him the exact steps that were executed to build this image. Of course, you can always document them to somewhere, but it will still be hard to manage, especially if there are hundreds of commands that were needed to perform to build this image. So in a sense, you have literally given him a black box, which is very hard to work with. I'm sure even you, the author of the image, probably would not remember how exactly you built it yourself. Although in some use cases you may not have a choice and you have to build or extend an image manually, nevertheless there is a better way to build a Docker image. Docker is able to build an image by reading instructions from a text file. The official term for that is Dockerfile. We will not be covering the manual process in this presentation because honestly we personally have not had a reason to use it in practice. Another important concept in Docker is a container. Without understanding the basics of it, it's very hard to understand how Docker works. From a developer point of view, a container provides an isolated virtual environment for your application that feels like a lightweight virtual machine. But architecturally, they are still different virtualization concepts. This means that your application process is virtually isolated from other processes running on the same machine. From an application point of view, there is little or no difference when running your application inside or outside the container. The inside looks most of the time the same like outside. Sharing the host's operating system kernel with other containers allows your application to be more efficient, but still giving you virtual machine-like capabilities. Containers are created from Docker images. In some cases, for example, you may need to debug a service that is running inside the container. Then Docker is able to give you a shell to a running container. A container can have a separate network interface or share a network interface with host's interface or with other containers. You can also control how much resources your application can have on the host. You may want to limit the memory, CPU, or disk space consumption to a specific value, if, for example, you run multiple containers on the same machine. Because you have such a fine control over resource allocation, Docker also gives you tools to get the necessary metrics for your application, which you can use to monitor your application performance. Containers are very lightweight. You could run hundreds, even thousands of containers on a single host. You definitely can't do that virtual machines. Starting a container takes most of the time, only a couple of seconds or less, usually the application or service running inside the container takes more time to start than the container itself. For some of you, the concept between a Docker image and a Docker container might still be a bit unclear. I once had to explain this to another Drupal developer that also didn't get the concept right away. So the alternative explanation I gave him helped him to better understand it. Most of you here are PHP programmers. At some time, you probably have acquired some knowledge about object-oriented programming. Try to think about the most basic concept of object-oriented programming paradigm, where you have a class and an object. A class is a blueprint which specifies the structure of data and the behavior of your objects. The same concept can be applied to the relationship between a Docker image and a Docker container. Docker image, in this case, is like a class that contains your application and all of its dependencies. And you can create containers that are derived from that Docker image, which then are created or destroyed on demand just like objects in PHP. So you can run multiple containers from a single image with different arguments to modify your application or container behavior on runtime. You can share a Docker image with other developers as easily as you can share a class that have been written to a text file. Just so you know, in the future, you could also share a running container with others by being able to create a full snapshot from it. But this feature is still in an experimental phase. I don't want to go into much detail about explaining you everything there is to a Docker file, because most of that you can easily find on the official Docker website. However, to get some better idea how Docker works, we still need to give you some basic understanding of it. Dockerfile, in a way, is a blueprint for your Docker image. It's a simple text file that contains a series of instructions on how to build an image. If you're familiar with Linux command line interface, then you basically already know how to write a Docker file. The only key difference between executing a command directly in terminal and in a Docker file is that the command in a Docker file doesn't expect you to interact with it during the image building process. So you have to construct your command that expects an input from a user during runtime in a way that all the input that your command needs are directly piped to that command in advance or using command line flags to make choices if a particular command supports it. A good example to illustrate this is installing Apache through a Debian package management system. By default, if you install a package with apt-get install without adding any extra flags, you will be prompted to make a choice. Either you can cancel the operation or continue with the installation process. But if you would let Docker engine to execute the same command from a Docker file, the build process will fail immediately because it's fully automated and doesn't expect any interaction from a user. By adding -y flag to your apt-get install command, a package will be installed without first asking your confirmation. Can you see it? Can you see the comments? Nope. That's bad. Can I zoom it somehow? Oh, yeah. Okay. It's a picture, so I can zoom it. Let's try to. Okay. Can you see this? Very good. Okay. This is how a simple Docker file looks like. You can build a Docker image from it that installs Apache on top of Debian file system, and it replaces the contents of the default index.html file with the sentence, "Hello Drupal Compose 2015. As you can see, the format of a Docker file is very simple. On the first line, you have a simple comment that is there to give you some insight about the Docker file. On the second line, at the left, you have an instruction, usually in uppercase, like in this case, the keyword from. And to the right, you have arguments for that instruction. Every Docker line in Docker file expect the comments are following the same pattern. So let's look into more detail about some instructions that are more important in this example. The second line tells Docker engine what is the base image that your new image will be built upon. In this example, it will be the official Debian image, which contains the files and directories which Debian itself is made out of. If a base image doesn't exist on your host at the time of building the image, it will be automatically pulled from the Docker hub or from a private registry. You can use every other Docker image as your base image. This gives us the flexibility to reuse already built images and increase the efficiency of the image building process. On line 8, 11, and 14, we see the run instruction, which is the most common instruction in the Docker file. Run instruction executes command and commits the change to file system back into your image. If you have not yet noticed then you can see that on line 11 we execute apt-get install with the -5 flag. So the build process wouldn't be interrupted. Fuck, you can't see the line numbers. Sorry. Okay, anyway, the last instruction is the entry point for a container. In this example, Apache will be started in the foreground if you launch the container. As long as the resulting process lives, the container will also stay running. If the process is killed inside the container will also stop. Now that we have covered most of the basics there is to Docker, so you will be able to follow the rest of the presentation, we are going to show you a small demo where you can see the Docker image building process in action. It's in video format, so. It's still a bit too dark, I think. As you can see, we are currently downloading Debian packages on Ubuntu. From the Debian repository. Inside the Docker, inside the container. And now we are going to start the container on port 80. So, there you go. In this little demo, we built a Docker image and started a container. Inside the container, Apache process were started on port 80. We also saw that making a HTTP request to the loopback address through the web browser, we got the actual response from the web server with the right payload. An action that only took about a minute to perform in practice took nearly half an hour to explain. So this should give you some idea how powerful it is to have a Docker in your development environment. It's your time.
So now we are going to talk about how we use Docker in our everyday work, which problems does it solve, and why we use it. So Docker, what? With this little demo, we have finished the first part of our presentation. We will now going to talk about why and how we at Phenomen switched our development environments from native LAMP setup to Docker to develop Drupal-based projects. Maybe you are right now experiencing the same problems as we did in our development workflow before discovering Docker, and our experiments using and deploying Docker within our team will give you the same insight how to resolve them. So the dark ages. Before deploying Docker to our development environments, the setup we had was not very efficient and scalable when working in a team environment. Our team is relatively small, and the amount of project each our developer has to work on work or maintain at any given time is quite large. Imagine having to work on 5 or more projects at the same time in same day, and more than half of those projects has not been developed even by you. So you don't know how this works and how to set them up in your environment. So it takes a lot of time and effort to put them up, even if it's only a 15 minutes bug which you have to resolve. So maybe the simplest bug is difficult to solve or develop from a junior developer, because it's pretty difficult to set this project up. Our experience has shown that the most who are affected directly by using this setup are front-end developers, because they start to set up a bit more. If they start to set up a bit more complex project by their own, they immediately get stuck, because the area of their expertise you need to have to work on your task does not belong directly to a front-end developer's domain. As you can see, there are many issues using this kind of setup and process in that work environment. So the accident. Now I'm going to talk why we started using Docker in our development. And this is a little story. Last year, in October, one of our junior developers was working on a project. He found the file permission for a project he was working was incorrect, and he thought he could safely resolve them by himself. But then happened this, and everything collapsed and didn't go as he planned. When he realized that the system wasn't working properly anymore, he notified a fellow colleague for help. After some investigation to his system, we found out that the command he entered was following. So processes running on his host were not able to properly access files and directories anymore. At first, we tried to recover as much as possible by hand, so he could at least continue with his work for the day. But the damage was already done. So the only choice we had was to reinstall the operating systems and configure all the tools that he needed in order to be able to continue work with his project. The time that the company had to lose from 2 developers that weren't able to write code for the rest of the day was pretty huge. If we would had a proper process in place that would have allowed us to build and configure everything automatically, the impact to the cost would have been much smaller. Learning from this real experience how things shouldn't be done, we started thinking about how to solve this problem and how to make our development environments more efficient. We learned that Jürgen had already played with Docker sometime, and by hearing him out, we came to the conclusion that trying to use Docker to make our development environments more efficient could actually work. So we came up with a plan: divide the process of deploying Docker to our development system into 2 phases. So phase 1. In phase 1, without first introducing large changes to our development system, we concentrated only eliminating problems we had when something would happen to our development machine and it couldn't be recovered easily. The first thing we did was that we moved all the services like Apache, MySQL, and PHP, etc., that were running on a developer machine natively into Docker. Docker containers. Every Drupal project shared the same Apache, MySQL, and PHP container instances. The other critical part to get right was Drush. How can we use it in a relatively comfortable way with containers? Because it's installed alongside with PHP service into the same image. If a developer wants to use Drush in containerized environment, he first has to go inside the PHP container, go to the Drupal install directory, and execute Drush commands from there. To solve that, we have to created a simple tool called Drush. You can install Drush directly onto your host and use it exactly like you would use it native, like you would use native Drush. Under the hood, by executing a Drush command, it first tries to detect if PHP container is running. If it isn't, it will ask you if you want to start it. Then it tries to identify if the directory you were executing your command is inside Drupal directory tree, and if so, it does a magic and executes the right Drush command inside the container. From a developer point of the view, most of the time he doesn't even know that Docker is the underlying technology that drives his project when using Drush. Since you can say that Drush in some sense is a version of agnostic wrapper around Drush, then you can use any version of Drush inside the container. For example, if you have to still support an old Drupal 6 project, which for some reason only can run on PHP 5.2, then the only choice you will have is to use Drush 5 or lower. The second issue that we had to resolve was networking. How to make it enough transparent for the ordinary Drupal developer that he could still develop his project without knowing how exactly Docker network works. As you may know, by default, when you link multiple Docker containers together, they don't share network interface with each other. It means that every other containerized service in your stack lives in a separate network, which you think is a good property to have in the long run. It solves problem when two or more random services wants to use the same port, but they each have a separate network. Then we don't have to be worrying about port conflicts. We found this tool called Socat and built it into our PHP Docker image. It allowed us to quite easily to redirect traffic from one network interface to another. So in our case, if the developer wants to communicate from PHP with an external service like MySQL that lives in a separate container and belongs to a different network, he still can use loopback address to communicate with that service. So from a developer point of view, nothing changes, and he uses it like the services are in same network. You should know that Socat is not perfect because it runs in user environment, in user space, and not in kernel space. So it can reduce the noticeable performance and slow down your project if you use bigger modules like views, panels, organic groups, and so on. Once these two major issues were resolved, we started deploying Docker solution to our developer machines that were willing to try it out and test. The feedback we had collected from them was very useful, and after fixing some minor issues, we already saw improvements from using Docker in our development system. For example, if one of the developers found a useful service or a tool that could improve his daily work, he made an image out of it, and by doing so, he immediately could share it with other developers that were using Docker, and it worked everywhere exactly the same way. Another example where we had the real opportunity to test it was when a new member became to our team. Instead of preparing the machine for development for a day before his arrival, we did it at the same time within 45 minutes, which also included installing the operating systems and giving him a small lecture about the environment, which is tremendous improvement from our previous approach to solve that problem. But we didn't stop there. And here is where the phase 2 comes in. We found the tool called Fig, which allows you to specify the configuration of a multi-container application in a single YAML file. Today, Fig is deprecated and is replaced with an official tool called Docker Compose. Instead of sharing Apache, MySQL, and PHP container instances between all projects on a developer machine, Docker Compose allowed us to use project-specific containers. This is very useful architectural change, primarily for one thing. When your Drupal project is different from the rest of the projects and it needs different or customized service to be able to run, with a shared environment, it's pretty complicated to maintain the differences between your services that are running in your projects. For example, project might need already support from PHP. If you are sharing a PHP container with all your projects, then all your projects will also have a support for that version of Redis. But what if another project needs Redis, an older version, another project needs an older version of Redis or whatever other service or tool in order to work? So managing a shared system where you absolutely have to use project-specific containers became extremely hard. Removing the shared system altogether and using an architecture where you only have project-specific containers running on your machine with Docker Compose is very easy to achieve. But to make that system efficient, you need to have some service and tools in place to support it. Since you could have hundreds of containers running simultaneously on your development environment, you need a way how to direct access them without wasting much time searching for them. The first tool we developed was vhost, that itself runs inside a container. The purpose of this tool is to constantly monitor your development environment and generate a list from all your running containers, which are displayed on a single page that you can access with your web browser on port 80 or 443. Under the hood, inside the container, runs Nginx that dynamically generates its configuration from the events that are emitted by the Docker engine. So if a container dies, it will be removed from the Nginx configuration, and if a new container is launched, a new entry will be added to the configuration. So by using this tool or your multi-container Drupal projects running on your machine are accessible through DNS. Another essential tool we have to develop to have a good experience working with Drupal using Docker is called Drupal Compose. The goal of this tool is allow you to easily generate Docker Compose YAML files for your Drupal 6, 7, and 8 projects automatically. So you can start developing your normal Drupal projects immediately that doesn't require any specific configuration. Most of our Docker images configurations can be changed on runtime when you launch a container. In practice, this means that if a developer, for example, needs to allocate more memory for his Drupal project, he can do it directly in the Docker Compose file. So he doesn't need to create another project-specific PHP image just to change the memory limit. The final component that we included in our setup was private Docker registry. All our Docker images that are specific to projects are stored in there. We can save a lot of time by building an image only once and pushing it into the registry. If every other developer just wants to use that image, they just pull it from the registry. So let's see how everything we have talked about in the second part of this presentation works in practice. So here we are installing Drupal basic installation and using Docker Compose and Drupal Compose to get the YAML file and set it up. So full AMP stack takes only 2 minutes to set it up, and it's fairly easy to use. Just check out the project, write in Drush. Drush takes care of the setting this project up. If it has a file, Docker Compose file, then it opens all the containers and voila. So here we are showing that even MySQL works in these configurations. At the moment there are no database created for this project. So we are creating a project database. And now everything works. So yes, this project takes only 2 minutes to set up, and it does not we don't need to make any changes to this project if there are any project specific things like memory limits or whatever Apache needs. And here is basically Drush status command, which shows that everything works. So in this video, we saw how the developer downloaded Drupal source code to his machine, created a standard Docker Compose YAML file for his project, and started containers with Drush. By using vhost, he was able to access Drupal and PHP MaiAdmin easily via the web browser. The last comment was there just to verify if Drush was able to communicate with Drupal as well. So now is the conclusion. By using Docker, our efficiency in terms of time and productivity has gone up greatly. Our developers are enjoying the development workflow that Docker can provide to them. So everything we have talked about in this presentation, including this exact presentation, can be found at dockerile.com. Feel free to use this material freely, and please contribute if this topic also interests you, so we can make it together even better. Thank you.
How much time do we have left? A minute. Okay, so maybe one question. One more question.
Did I understand that you use this for deployment also, or not?
No, it's only for our development environments. The deployment to another machine is another topic.
So are you working on it? You are going to do it?
Yes,
Yeah.
it's a phase 3 that we are aiming to achieve, but at the moment we are not using Docker for that, only for our development environments.
Questions?
I think you can still ask some questions if you have. Okay, thank you.
Thank you.